Hello students, welcome to the class. We are going to start the fresh and new chapter, that is your wave optics. And this wave optics is also known as your physical optics. This is also known as your physical optics. Physical optics, because it gives the answer to a question, what is light? We will go into some historical background for explaining what is light, but you should understand it very carefully that people from the beginning of civilization were interested in knowing the nature of light. Different mythology, different theories, different religion gave their own way of interpretation of light, and they explained the behavior of light and all other things. But that we have not included in the study of physics, because that is not a scientific study. The scientific study of light first began with the Newton given concept, and that is known as corpuscular theory of light. So Newton gave corpuscular theory of light. Newton gave corpuscular theory of light. Here the year also you will have to remember, that was in the year 1675 AD. This was the year, because date will help you in understanding the development process in the proper way. So in Newton's corpuscular theory, the word corpuscular has come from, this word has derived from corpuscle. This word has derived from corpuscle, which means very small particle. Very small particle, invisible. This is so small that it is not visible to you. So corpuscle is this, and the biology students might be knowing that there is red blood corpuscle, white blood corpuscle, like that only. So corpuscle is a very tiny particle. Next thing is there, while giving the corpuscular theory of light, Newton made certain ad hoc assumptions. Ad hoc assumptions. Why Newton made ad hoc assumptions? Newton made ad hoc assumptions due to the fact that at that time technology was not so developed that it will support the development of science and scientific theory. So certain assumptions were made by Newton. In that ad hoc assumptions, he supposed that speed of light in denser medium is more. So first ad hoc assumption was speed of light in denser medium is more. Now this was incorrect. Later on it was proved that it was incorrect, but at that time, for the explanation of various different phenomena of that time, Newton assumed that the speed of light in denser medium is more. And in order to explain colors, he assumed that second assumption was that size of corpuscle for different color is different. This was the next assumption he made, and he also assumed that any body emitting light basically emits corpuscle. Light emitting body, from where we get source of light, emits corpuscle, that is tiny particle corpuscles, and when these corpuscles fall fall on our retina, they give the sensation of vision. He explained many phenomena of light of that time, of this time, and in that phenomenon he explained shadow formation. He explained the phenomenon that was explained by Newton's corpuscular theory was first shadow formation. Shadow formation. Shadow formation was the phenomenon that was successfully explained with the Newton's corpuscular theory. Then he explained rectilinear propagation of light. Then he explained rectilinear propagation of light. This theory also explained reflection, and finally it explained refraction. Refraction of light. While explaining reflection, Newton assumed that the reflecting surface basically repels the corpuscles. And while explaining the refraction, he explained that the denser medium attracts the corpuscle, on account of which speed of light in denser medium increases. These were ad hoc assumptions and later on proved wrong. When Newton gave this theory, in the same time, when Newton gave this theory, in the same time, a scientist was there, a young scientist was there, who gave the wave theory of light. A young scientist was there who gave the wave theory of light, and he suggested that light is a wave. At that time, the name of that scientist was C. Huygens. He was a Dutch scientist, and he said that light is a wave. So, in the year 1678, try to get the development of theory. So I am mentioning the date. It will help you in understanding the development process in a better way. So in 1678, the scientist was C. Huygens. The scientist was C. Huygens. C. Huygens gave the wave theory of light. Wave theory of light. C. Huygens gave the wave theory of light. Now, in this wave theory of light, Huygens suggested that light is a wave. Light is a wave. And Newton what said? Light is a particle. Newton suggested that light is a particle, whereas Huygens suggested that light is a wave. Which type of wave? Longitudinal wave. Longitudinal wave. Why he said light as the longitudinal wave? Because while discussing at that time, sound was known to the physical society. People have the idea of sound, and they were knowing that sound needs a medium and sound is a longitudinal wave. On that basis only, Huygens said that light is a longitudinal wave. While light is a longitudinal wave, then for longitudinal wave a medium is required. So at that time it was again ad hoc assumption, hypothetical assumption of Huygens that the entire space is filled with a medium that has got a particle that has got a hypothetical medium that has called luminiferous ether. Luminiferous ether. Later on it was also proved incorrect. It was also not correct that the entire space is filled with luminiferous ether. This was the particle, whole universe, whole entire space is filled with this hypothetical particle, and it was the assumption of Huygens. And also Huygens, when said this thing that light is a longitudinal wave, and he explained certain phenomenon. These phenomena were not explained by Newton's corpuscular theory. So what theory Newton's corpuscular theory was not able to explain? Newton's corpuscular theory was not able to explain Newton's theory failed to explain interference. Interference is the phenomenon of light. Newton's theory failed to explain interference, diffraction, polarization, and some other phenomenon. So this theory was not successfully explained by Newton's particle theory. But when Huygens gave the wave theory, the phenomenon of interference and diffraction was successfully explained. But you see the time. Huygens was a contemporary scientist of Newton. At that time, nobody was ready to accept what Huygens was saying. So Huygens theory was not accepted for year 175 years. For 175 years, Huygens theory was not accepted to the society, physical society especially, I am telling. When in the year 1850, in the year 1850 AD, there was a scientist named Foucault, F-O-C-A-U-L-T. There was a scientist Foucault who measured the speed of light and suggested that speed of light in denser medium is less, while Newton said speed of light in denser medium is more. So as a result, what happened? As a result, there was a experimental contradiction in the Newton's assumption and the experimental result. So finally Newton's theory was discarded. But you should understand that it was the first scientific study of light. So it was telling something scientifically about light. So it ruled the society. It was available in the society for about 175 years. After that, what I would like to tell you, see carefully. In the meantime, Huygens supposed light to be longitudinal wave, but the scientists were there named Fresnel. Spelling is Fresnel, but pronunciation is Fresnel. And the scientist is there, Young, Y-O-U-N-G, Young. These two were the scientists who proved that light is not a longitudinal wave. This was not correct. Light is a transverse wave. This was proved by the two scientists, Fresnel and Young. Now, in the meantime, in the year 1873, there was a scientist whose name was Maxwell. So he gave the theory, electromagnetic theory of light. Electromagnetic theory of light. This was the given by Maxwell. Maxwell was the scientist who said light is an electromagnetic wave. Electromagnetic means it is related with electricity also, and it is related with magnetism also. So you should understand it very carefully that changing electric field gives rise to magnetic field, changing magnetic field, and changing magnetic field gives rise to changing electric field, and the result is electromagnetic wave. So Maxwell suggested that light is an electromagnetic wave, and in wave section you will read that electromagnetic wave does not require any material medium for its propagation. Therefore, the electromagnetic wave, light, which is transverse in nature, does not require any material medium for its propagation, and it can travel in vacuum also. This was the electromagnetic theory of light, and the Harj theory was not able in explaining the phenomenon of polarization. This polarization phenomenon was not explained by Harj using the wave theory, and this was explained by your Maxwell theory, who gave the electromagnetic theory of light. So Maxwell's electromagnetic theory explained almost all phenomenon. Phenomenon means optical phenomenon, all phenomenon of that time. It explained all phenomenon at that time successfully. There was a scientist named Harj. Harj is the unit of frequency, and this frequency unit is based on the scientist word that Harj. Harj is the unit of frequency. So Harj was a scientist who experimentally produced the electromagnetic wave into laboratory. So ultimately electromagnetic wave was produced, but accidentally at the same time Harj only discovered a phenomenon that is known as photoelectric effect. So I am writing here photoelectric effect. Photoelectric effect. This photoelectric effect will be taught to you in detail in your modern physics. In modern physics, it will be taught to you in detail, and this photoelectric effect was not explained by using electromagnetic theory of light given by Maxwell. So again the problem came. When this problem came for the explanation of photoelectric effect, later on in the same time Einstein proposed the quantum theory of light. Einstein proposed the quantum theory of light, and that quantum theory of light, in which he used the Planck's quantum concept. And said that light is made up of photon. So the next theory came, that is fourth, the quantum theory of light. Quantum theory of light. This was given by Einstein using Planck's quantum concept. And what is Planck's quantum concept? Planck's quantum concept is that light is made up of packets, particle-like packets, energy packets. That is known as photon. So photon is the energy packet, or in fact it is the packet of energy, and energy of one photon is given by h nu, where h is the Planck's constant and nu represents the frequency of light. It is the frequency. It is representing the frequency of light. Using this concept of quantum theory, Einstein was successful in explaining the photoelectric effect. And thus it was the year 1905 when Einstein was awarded with Nobel Prize in Physics. Nobel Prize in Physics was given to Einstein for the successful and correct explanation of photoelectric effect. Later on, the whole physical scientific world was divided into two groups. One group was in the favor of wave phenomenon of light. Light is a wave. One group was in the favor that light is a wave, whereas other group was in a favor that light is a particle. So ultimately, in the same time, de Broglie's hypothesis came, in which wave particle duality, dual nature of matter and radiation was given by the de Broglie's hypothesis, and finally it was acceptable, the final theory, it was acceptable that light has a dual nature. When light has a dual nature, it means that sometime it behaves as particle and sometime it behaves as wave. Now these two behavior of light cannot be separated. They are the two sides of the same coin which cannot be separated. One side phenomenon will be explained by particle nature of light, other side phenomenon will be explained by the wave nature of light. When the dimension of the object which of our concern, of our use, on which we are studying the behavior of light, is very large as compared to the wavelength of light, then the subject matter comes into ray optics and we study the ray optics like shadow formation and all these things. In the same time, if the dimension of the object or obstacle is very small, it is comparable to the wavelength of light, then the wave optics basically comes into picture, and wave optics we explain and we study light as the wave nature. Now what I would like to tell you, this was the background of your development of theories of light. Keeping this background in mind, we have to basically concentrate on the theory given by Huygens, known as wave theory of light. So in wave theory of light, what is required? So basically we have to, the subject matter of our wave optics is the wave theory of light. In short, I would like to recall that whole theory development process will be helpful in understanding the wave theory in a better way. So now we will focus on the main concept, that is wave theory of light. So we are now trying to understand the wave theory of light, and in the wave theory of light given by Huygens, light travels in the form of wavefront. Light travels in the form of wavefront. So first concept is your wavefront. Wavefront, light travels in this wavefront. Name was given by Huygens. Huygens gave the name wavefront. So light travels in the form of wavefront. Light travels in the form of wavefront. Now what I would like to tell you, what is this wavefront? This wavefront concept you can understand that in the pool of water, in the water pool, if we drop a stone, the moment we drop a stone, we will observe that circular ripples develops and it starts going in outward direction. You might have observed this is going in outward direction. It is going in outward direction. So when it is going in outward direction, you will observe that this represents your wavefront on the surface of water, and this is basically circular wavefront. This is basically circular wavefront. Now the question arises that what is the uniqueness with this each circle? In order to understand the uniqueness of this circle, these circles, we have to understand some concept of phase, that what is the phase here. See, according to Huygens, light travels in the form of wavefront. if I suppose a disturbance is here, source of disturbance is here, Huygens suppose light to be longitudinal wave, so it will be giving to its neighboring particle, and in this way the light will propagate. We have to understand, I will have to explain a word that is homogeneous. I have to explain a word homogeneous. Homogeneous. And second word is isotropic. Homogeneous isotropic medium. What does it mean? Homogeneous medium means, same density, and isotropic means in all directions the permittivity and the permeability. Two words I am using. Homogeneous. This tells about same density, uniform density, and isotropic. This isotropic basically tells about same permittivity and same permeability. In all direction. Same. One word is there, that is permittivity. Permittivity, basically electrical property of medium is there that you have read in your electrostatics, and permeability is a magnetic property that of the medium that will be dealt in the magnetism portion detail. I will tell you about this, but basically you have to understand that medium should be homogeneous and isotropic. In this medium we are supposing that the wave is propagating in this way, and this is homogeneous and isotropic medium. So this thing has to be used, this I will be using frequently in the discussion of wave front. So this thing should be clearly understood in mind, that what is homogeneous and what is isotropic. Now after this, as I was trying to discuss with you the concept of wave front, in that wave front it has to be kept into mind that wave front we are talking in homogeneous and isotropic medium, and also you will have to keep this thing in mind that Huygens supposed light to be a longitudinal wave. So if the light is longitudinal wave, here in the medium if disturbance is created, this will transfer our disturbance to the neighboring particle, that will be giving to the neighboring particle, that will be giving to the neighboring particle, and in this way, suppose at this point P1 the wave has reached at this point, and in the isotropic homogeneous medium, c is the speed of light. Speed of light is c. C is the speed of light. If c is the speed of light, the time taken after time t is your time. After time t, the wave has reached here. So this distance will be your ct. In the same way, you will observe that in this spherical region, you will be observing that here, P1, P2, P3, P4, take this point as P5, the wave is reaching and the distance is ct. So this is not a circle, this is a sphere, that is, it is three-dimensional in nature, and in all these points the wave is reaching at the same time. So as whatever is the source frequency, the same frequency will be here also, the same frequency will on this surface. This is a surface of same phase. This is the surface of same phase, and this is being called as your wavefront. Wavefront. This is being called as your wavefront. So this is the basic concept of surface of same phase that is being called as the wavefront, and this was the concept of Huygens, who gave the concept of wavefront and said that this is the wavefront. Now after understanding, so how can we define the wavefront? We can define the wavefront as wavefront is the locus of all points. Locus means path. Locus of all points vibrating. Locus of all points vibrating in same phase. Vibrating, locus of all point vibrating in same phase and at a time. So wavefront is the locus of all points vibrating in same phase at a time. Here a very important question, that is the part of entrance, and in entrance this is very important question that is frequently asked. Keep and think about it, that if the question is being asked in this way, that on a wavefront, suppose the question is asked in this way, on a wavefront, what is the phase difference between 2 points? Think about this question, just think and then try to understand the solution. So my question is there, which is very popular in entrance also. In entrance this question is very popular to make you understand what is the phase difference. What is the phase difference? What is the phase difference between 2 points on a wavefront separated by a distance of 5 centimeter. Generally, and 4 options will be given to you. Out of those 4 options, what I mean to say, generally the students use the concept phase difference delta phi is equals to 2 pi by lambda into delta x, path difference, and then, or better you say 5 lambda, 5 centimeter or say 5 lambda. So you will be getting here, that will be giving you 2 pi by lambda into 5 lambda, and lambda will cancel, you will say 10 pi. So 10 pi is the phase difference that you generally the student gives the answer, but it is not correct. Why it is not correct? What I said, that wavefront is the locus of all point vibrating in same phase. So if the distance is 5 centimeter, here is the phase is suppose phi 1, then here should also be phase phi 1, because it is the wavefront. So when it is the phi 1, it is phi 1, the answer should be 0. So phase difference is 0. Don't confuse by this answer that it should be 10 pi. Phase difference is 0. Why? Wavefront is the locus of all. It is similar to your equipotential surface. You might have observed, you have read in electrostatics that the similar concept is there in the equipotential surface, that on equipotential surface what is the work done in taking the charge from one point to another point separated by a distance of 5 centimeter. As potential difference is 0, so work done is 0. So work done is 0, that is the answer. In the similar fashion, here also the phase difference between 2 points on a wavefront separated by a distance of 5 lambda or whatever value, whatever separation is there, is 0, because wavefront is the locus of all points vibrating in same phase. So this should be clearly kept into your mind. Now after this, what I would like to discuss, I would like to tell you about the types of wavefront. I would like to discuss the types of wavefront, that according to the shape, the wavefront is divided into different groups. So for example, I would like to tell you, see carefully, if I say that types of wavefront, now we are studying types of wavefront, types of wavefront. In the types of wavefront, what I mean to say, first type is spherical wavefront. Spherical wavefront. In spherical wavefront, you should know that the source of light should be point source of light. Source of light should be point source of light. Now, point source of light is there. Generally, a wave is represented by this way. Here you see. This is the wave. Here if you see, the phase is 0. Here at this point crest it is pi by 2. Here it is pi. Here it is 3 by 2 pi. And here it is 2 pi. Generally the representation of wave is this only in terms of phase. Now if I want to say you that suppose here is the source of light and the similar wave will be generated. This gives, arrow gives the direction of ray. Energy is moving in this direction, outward direction. You see, I am trying to show you that here you see, I am trying to show you. Now this is the, here is the source, here is the source, and this source is generating wave. Now one wave I can take in this way, another 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 wave I can take in this way. Similarly, here can be the wave. Similarly, here can be the wave. Now, this is the general wave I have made. If you will see this point just after the crest, just after the crest, this is your pi, 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 and finally this is your pi. So these points are on same phase. If I join it by a dotted line, what you will observe? You will observe that this type of spherical structure surface is being formed, and this is your wavefront. Why? Everywhere the phase is pi. Here also pi, 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 pi and pi. So this is the surface of same phase. Similarly, if we take this point here, phase will be 2 pi, and if the phase is 2 pi at all this point, we will, what we will do, we will make it, join it by a spherical surface because it is 3-dimensional. This is your another wavefront. So another wavefront is coming. You have got another wavefront. Similarly, if you will join this point, trough, you will be getting the another wavefront. You see. So if I am joining the trough, we will get the another wavefront. Here you see. It is also spherical in nature. See here. It is also spherical in nature. So this is also spherical, this is also spherical. So we are getting the spherical wavefront. You can join this point also of same phase, that is pi by 2, and you will be getting here, 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 and you will be getting this also as wavefront. So these are representing your different spherical wavefront. What does it mean? These are basically the surface of same phase. So it is your spherical wavefront. It is your spherical wavefront. If we talk as the spherical wavefront, it can be converging also, or it can be diverging also. So what this arrow indicates? Arrow indicates the direction of ray, that means in which the energy propagates, or the direction perpendicular to the wavefront. So arrow represents the ray. So how can we understand the converging spherical wavefront and diverging spherical wavefront? In order to understand the converging and diverging spherical wavefront, we will have to use the concave and convex lens. We are supposed to use the concave and convex lens for diverging and converging wavefronts. So if we take a wavefront from here, you see they are parallel rays are coming, so they will converge at this point. When they are converging at this point, this is the wavefront that is converging in nature. This gives the direction of ray. So this is the wavefront that is converging in nature. This one thing you should understand. This is converging spherical wavefront. If you want to understand the diverging spherical wavefront, we can use the concave lens. Concave lens can be used, and you see here is the spherical wavefront, here is the ray that is going in this way, so it will go in this way, it will go in this way, and here at the point behind focus here. So what you will observe? You will observe the wavefront in this way. You see. With time, this is your diverging wavefront. This is giving you diverging wavefront. So spherical wavefront we have seen, diverging wavefront we have seen. Now this was all about the point source of light. This is your diverging wavefront. Now we have to talk about the we have talked about point source of light, but it is not always the point source of light. Bulb can be treated as a point source of light, but you cannot say that tube light is the point source of light. If the source of light is like a tube light, then it is the extended source of light and linear source of light. So second type of wavefront is your cylindrical wavefront. Cylindrical wavefront. Cylindrical wavefront is what? Cylindrical wavefront is that for this you need a line source or linear source like tube light. Linear source. If line source is there or linear source of light is there, then like tube light, then we will get cylindrical wavefront. Suppose for example, I am making first cylinder, and here you observe, here you observe, here you observe, here you observe. Arrow gives the direction of ray. Arrow gives the direction of ray, and this is the line source. This is your line source. So different coaxial cylinders with line source at the axis represent, this size will goes on increasing. So this is your cylindrical wavefront. Finally comes the plane wavefront. Plane wavefront is like this board, that one surface, other surface, other surface, other surface, like that only we are getting the plane wavefront. Plane wavefront. Plane wavefront. This plane wavefront is the part of a spherical or cylindrical wavefront. See here, see carefully. If this is the spherical wavefront, you see at a large distance what you will observe, it will nearly become plane. So when it will become nearly plane, it is represented by this way. Here you see, this is representing your plane wavefront, and arrow represents the direction of ray. Arrow represents the direction of ray, and this is your plane wavefront. Similarly, so plane wavefront is only the part of a spherical or cylindrical wavefront when the source is at a very large distance. Now, I hope that with this much background of the discussion of history of optics, together with the understanding of an introduction of wave optics and the concept of wavefront, it will empower you to understand the concept in a better way, and it will be helpful to you. Thank you. Have a nice day.